Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson. Today we're going to be talking about a problem involving related rates. So, if you have any questions, please feel free to put them in the comments below. If you have any other problems, feel free to put them down there as well. So let's jump into this problem. We're told that melted ice cream is dripping out the bottom of a cone at a rate of 3 cubic inches per second. The cone has a height that is 4 times the radius of the top. How fast is the depth of the ice cream in the cone decreasing when the height is 8 inches? So, with any related rates problem, there's going to be some sort of geometry or some sort of physics formula that we're going to need in order to work on the problem. We've got to come up with that. We've got to find it. So, what we're asked to find here is how fast is the depth of the ice cream cone decreasing. So if we have an ice cream cone, bring that up here, and we look at the dimensions of this ice cream cone, we see that we have a radius right here, and we also have a height. And what we're asked to find is the change in the height. So we're asked to find what is dh dt when h is equal to 8. So we need to figure out how to come up with this differential, this change in height with respect to time. So what are some of the other things that we're given in this problem? Well, we're told what the change in the volume is right up here. So we know that dV dt is equal to 3, or to -3, because the ice cream is coming out, cubic inches per second. And we're also told that the height of the cone is 4 times the radius of the top. So the height is 4 times the radius of the top. So we've got all that information down now. So what formula now are we going to work with? Well, since we've got the volume, or we have the change in the volume, it probably would make sense to look at the volume of a cone. So the volume of a cone here is equal to 1/3 pi r squared h. And if we think about the ice cream in this cone, then it should make sense that as the ice cream is melting, it's coming out the bottom here, that the radius of the ice cream and the height of the ice cream is changing as time goes by. So both r and h are changing with respect to time. So what does that mean then? So that means that we can take the time derivative of the volume equation, take the derivative with respect to t, and we will have the derivatives of volume and radius and height all involved in that derivative. But since the radius and the height are both functions of time, when we get to r squared h over there, we will have to use the product rule to take the derivative. There are different ways of doing this. And you're free to choose another method if you like, but this way kind of gives us the most direct and kind of the clearest path to what we're actually doing. So let's take the time derivative of the volume equation. So we'll take the time derivative of the left-hand side, and we'll take the time derivative of the right-hand side. Now, since 1/3 and pi are constants, we can bring those outside. And on this left-hand side, I'm just going to write that as dV dt, because I'm taking the derivative of the volume with respect to time. I'll take that 1/3 pi out, and then I get the derivative with respect to time of r squared h. So I'm going to need to use the product rule on that. So we take the derivative of the first. Remember that if we have a product, right, some f times g, and we're taking the derivative, then that becomes the derivative of the first times the second plus the first times the derivative of the second. But because we're dealing with r and h, none of those have t explicit in them. When we take the derivative of r, we're going to get dr dt. And when we take the derivative of h, we're going to get dh dt. So let's start this off here. So we get 1/3 pi. And then we take the derivative of the first term. We take the derivative of r squared. So using the power rule, the 2 comes down front, leaving the r alone. And then you have to use the chain rule. Take the derivative of the inside, which means that becomes dr dt times the second times the height plus the first, so plus r squared, times the derivative of the second. So that's just the derivative of the height with respect to time. Nothing cancels, nothing goes to 1 or anything like that, because we're not taking the derivative with respect to h or with respect to r, we're taking it with respect to t. So let's take a look now at what we're trying to find. We know dv dt. We should be able to figure out what r is. We know what h is. dh dt is what we're looking for. So that's our goal right there, is to get that amount right there. But what we don't have is dr dt. So what is this? So looking back up at our equations here, we have another equation that we haven't used yet. We have that the height is equal to 4 times the radius. Go back up here and look, right? The height is equal to 4 times the radius. Well, that's something that we can take the derivative of. So I can take the time derivative of both sides, and that will give me some information about the derivative of r with respect to time. So if I continue this, I get dh dt is equal to 4 times dr dt. So what does that tell me about dr dt? Well, that tells me that dr dt is equal to 1/4 dh dt. So now I have everything that I need. Okay, so there's my derivative. So let's start plugging things in. I know from the problem that dv dt is -3, and that's going to be equal to 1/3 pi times 2 times the radius. Well, if the height is equal to 8, I know that h is equal to 4 times the radius. If the height is equal to 8, then the radius must be equal to 2. So we have 2 times 2 times dr dt. And so we found out that dr dt was actually 1/4 dh dt times the height, which was given to us as 8, plus r squared, which is 4, times dh dt. So now if you look at this problem, we only have one variable. It's just dh dt. And now we can solve it for dh dt and we'll get our answer. So start to clean this up a little bit here. So -3 is equal to pi over 3 times 2 times 2 is 4, divided by 4 is 1. So this is 8 dh dt plus 4 dh dt. So keep going. So that's -3 is equal to pi over 3 times 12 dh dt. So the 3 and the 12 reduce. So we get -3 is equal to 4 pi dh dt. And if we divide both sides by 4 pi, we get that dh dt is equal to -3 over 4 pi, and the units will be inches per second. So that should make sense. The ice cream is dripping out of the cone, and so the change in height should be negative. And when the height is 8 inches on this very large ice cream cone, then the change in that height is going to be negative 3 over 4 pi, or about a quarter inch per second. And that should do it. That answers our question. Thanks for watching, and I'll see you in the next video.